Dick Dunne of GPI is going to come and talk to us about link slabs for joint elimination. Very consistent with what...
Yeah, good afternoon. I'm the last guy before we get out of here today, so that's why they put the guy from New Jersey on here, because he talks fast. But also, I think Christopher wins the farthest away award, right, from Nova Scotia to here. I think that's got to be the farthest away award. The nice thing about my presentation is it builds upon a lot of the other presentations you've seen here today and even in this session. So I won't have to talk about too much stuff. I can go a little bit quicker because of that. So I want to talk to you all about eliminating deck joints with link slabs. And it's really kind of a hot topic, actually, and that's kind of what Bijan Khalegi said on this TRB webinar that was held in June, this over a year ago now, and we're talking about how you can replace deck joints with link slabs. And it's not only was it on a webinar, it's also now in the service life design guidance. There's a discussion about that, having UHPC link slabs. There's also a discussion about that in the NHI course, 134062 Bridge Rehabilitation Design. This shows a link slab being built in Massachusetts. And the last thing that I just wanted to reference was the EDC Link Slab Day about 1 year ago, where they basically talked all about it. So hopefully some of you were able to, participate in some of these things where we're talking about this and our understanding of what's going on. So the question is, why is this such a hot topic? Well, the reason why it's a hot topic is, as we've seen, leaky joints tend to deteriorate the end of your beams, pier caps, bearings. Jeff Milton's quote is, "The only good joint is no joint." And, Bill mentioned that I'm a friend of the partnerships. Well, my first friend in the partnerships when I was the state bridge engineer in New Jersey DOT was the bridge maintenance engineer from New York called Pete Wycamp. Some of you may know him. He was a great guy, and he had three mantras as the state bridge engineer of New York. It was all concrete cracks, all steel rusts, and all joints leak. So in keeping with that, we wanted to try and figure out what we can do about this. And in the bridge preservation, FHWA's bridge preservation guide, we even talk about joint repair, joint replacement, and joint elimination. So how is that done? What are we talking about? And we've seen some things here today. The Bridge Preservation Expert Task Group, under Roger Laney's guidance, put together a case study, and that's what I'm going to be talking about today, is that case study, which GPI authored with a lot of help from the Bridge Preservation Expert Task Group. The partnerships all were able to provide comments to us on it. So this is what I wanted to talk to you about. So the case study, as case study implies, we talked to different agencies to kind of come up with what people are doing here. So we have New York State DOT, Massachusetts DOT, Virginia DOT, and Maryland Transportation Authority. So they're all taking a little bit different tactics to it. So we thought that's kind of the essence of having a good case study, is you can see things that, maybe you don't have exactly the same thing as New York, but you might have something where if you look at what New York's doing and then you kind of compare it to what Massachusetts is doing, you could kind of mix and match and bring it together for your state and your needs. There's a couple different ways that you can do this. You can do a partial or full depth link slab, and this is just kind of showing it schematically. But as Christopher talked about, what happens is you change your point of translation and your point of rotation. And sometimes when you're doing this, you need to think about whether you need to replace your bearings as well when you're doing the link slab replacement. And a lot of times there's so much deterioration there that's kind of a natural fit, right? That you either replace them or revise the way they work. This is what they did up in New York. They did actually replace the bearings. That's a picture of what they did up there. The other thing that Virginia's doing, and actually Maryland's doing too, is they're looking at not only using ultra-high performance concrete because of the features that ultra-high performance concrete have. Another type of concrete, the engineered cementous cementous, it's easy for me to say, concrete is has similar properties to ultra high performance concrete. And so Virginia DOT is has used that, as well as will come to Maryland Department of Transportation as well. This is all about being flexible, but also being very durable and having very tight porosity so that you don't have areas for the water to get in. This is right out of New York State's DOT's design manual. This is what they do. This shows you have reinforcing carrying across your joint now. They have a bond breaker, and then they pour the link slab there. And this is a picture of that in place. And what you'll see here, and this is something that Graham talked about, you can see the forming. You have to put the formwork on top, and it's got to be pinned down, because the concrete, if it flows up, you can't grind it. It's very, very difficult. So this is how you have to do it. You have to have ports, and you basically have to do it this way. So I just wanted to bring that to people's attention, because that's important when you're doing that. But this is, you can see you need to have lane closures and things like that. So it is something that you need to use some standard traffic control and things like that when you're doing. And this is a picture of Virginia's detail. I know it's busy, but you can see that it's fairly similar to what I was showing you from New York State. New York State's got some new reinforcing in there, and you can see here Virginia's got theirs in there as well. So we have some good pictures and details. Virginia also has this deck extension, and it kind of goes along with what we heard Jason talking about, the kind of the floating bridge here. This extends at the abutment, so that it pushes the joint off the bridge and allows that the water to be pushed off there. Now, again, that's got to be taken care of so that it doesn't just roll down the back of your abutment and wash out in front of your bridge. And Christopher did a really good part about this, and I'm so, as somebody who's been removed from the hard, detailed design, I was struggling on this, and I was like, oh, Christopher covered it in detail. All the work that you have to do. You can't just go ahead and say, oh, we're going to do this, just go out there and let your maintenance crew do it. There is backup design work that needs to be done. When you're doing a simple link slab, it's not quite as detailed as what Christopher had to do on their job, but you do need to make sure that it works, or else you're going to get cracks, and it's not going to, it's not going to do what you want it to do. You do need to take a look and see what's going on. And we run through this in the case study, so you have some design examples so that you can kind of figure this out and look to see, how it works, if it'll work in your case, and if not, you can figure out what you have to do to make it work in terms of adding steel or doing those types of things. In the case study, we have a nice summary of all the different things of how they do it, what the length of the link slab is, how much reinforcement do they put in, what's the spacing on that reinforcement, that sort of thing. It's all detailed in our case study, which is on FHWA's website under the bridge preservation. I do give a link here at the end. What was interesting was, so some of the states that are doing this, right, Maryland, New York, and Virginia have been doing it for some time. So you talk to them, and it's like, yeah, it's just a matter of course. You don't know what they were thinking. And if you're not doing it now and you want to do it, you're thinking to yourself, well, maybe we should do a little bit of research. Maybe we should understand what's going on. And that's actually what Maryland did. And they were actually doing their first applications, and they had the University of Maryland doing research for them. What they found out was that, thermal movement with modified boundary conditions is more desirable than increasing thermal stress. They have a bunch of recommendations from there. And they basically found out that, both the ECC and the UHPC link slabs are feasible and are doable. And, that gives you a little bit, as we've heard before, and as if you've sat through any of the UHPC presentations, it's pretty expensive. Now, ECC is a little bit less expensive, but it's still not the same as just concrete that you'd be using for regular deck, regular abutments, that sort of thing. So there's a whole nice link to this report. But again, it kind of verified what Virginia, Massachusetts, New York, and even other states. I know New Jersey's done a little bit of this as well. So, what are the conclusions from the case study? They're great for deck preservation link slabs. UHPC is a good material. ECC seems to be performing well as well. There's some great details from New York State DOT, Virginia DOT, Massachusetts not there. It's not on the list, but they are. And then we have, like I said, some really current research from MDTA. There's some great resources here in the case study that we looked at to try and pull this all together. Again, that's why it's really a great resource for folks. That's the link to it. It really, you just go to FHWA's webpage, infrastructure, bridge preservation, and it comes up as FHWA. But, eliminating joints is a good idea, but why was the joint there in the first place? You have to understand that, right? You do have to do your engineering analysis of what has to be done. You got to follow the loads. You do need to do some sort of analysis. We think that that's important. And I will say this, if you come to these regularly, there's a whole bunch of joint manufacturers in here. And as much as I said, and I quoted my friend Pete Wycamp that, all joints leak, that's true. But if you do your work right in terms of when you design it and you get the contractor doing it right and you have the opening right for your temperature, you can install a joint that the folks in that other room will provide for you, and it will last a good long time. But this is what happens after, when things wear out, So the idea is what can we do to make that not have a problem. With that, I am going to stop talking and let you all question me, and I'll probably defer everything to Bill because he knows all. No more than any other cold joint. They do use the details do show to use a sealer there to seal that, like you would seal a crack, if you will, to prevent that from being a problem. Make sure that it allows that movement, in terms of the whole, the rotation and things, because that's part of how you have to do that analysis of what you're actually doing when you connect the slabs, right? You have to figure that out. I personally don't know. I'm not sure if we have a quote for that in there. UHPC is the strongest concrete I've ever seen, so it's going to last longer than the rest of your deck. And the cost it depends on how much you're doing. One thing about the cost is it's a really costly material, right? But it's a small batch that you're putting in there, and you got to do traffic control, and you got to do other things so that cost, while it might be a lot for that, what we would consider a lot for concrete for that small batch, it's really not, it doesn't dominate the cost of your repair that you're looking at you're doing. So I apologize I don't have a better idea, but if you talk to some of these people, look at what's done there, I think you might be able to find some information on that. Basically, basically you need to do whatever your state has, that you can do on a SKU. Like, I think it's a 45, is it 40? I'm not sure, Walt. I think it's in there, though. There's a limitation on SKUs. Yeah, I think it might be 30. I'm thinking, yeah, I believe, So there is a concern there. Now, as we heard earlier today about making bridges continuous and pushing them to the limit, our good friend Ed Wasserman pushed those limits way out. So there may be, I'm sure there are people here who would be willing, as Graham said, to just take that risk and say, we're going to push the envelope here and see what happens. Put it on a 40 degree or 45 degree. If you really have a problem, then you might want to think about it. So the railing still has a joint. I believe the railing still has a joint in it. So you just bring that back so that you have the joint there. So you wouldn't necessarily. Yeah, I don't think you necessarily touch that because actually, let me see if I can find that. I think the New York one, yeah, that shows they took the railing out there. Oh, for the median, yes, for the median in between, you would close that up as well. But I think if you had the aluminum rail on on the outside of the bridge, I tried to make it fast. So.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.